Projecting activity diagram of SYSML from SBC process algebra. I'm Dr. William S. Chow. Chapter 1 SBC process algebra is the meta model of SYSML. SYSML uses 9 diagrams to describe a systems model. However, they are inconsistent between them. Therefore, we need SBC process algebra to ensure consistency between these different diagrams. Because SBC process algebra is the meta model, therefore, activity diagram of SYSML can be projected from SBC process algebra. That means activity diagram will be a projected view of the SBC process of a system. Chapter 2 talk about SBC process algebra. SBC stands for structure, behavior, correlations. SBC process algebra really integrates the structure and the behavior of a system. SBC process algebra is a language, a modeling language. Therefore, it has entity, tokens, or syntax, or semantics of a language. SBC has many entities such as operational code or operational return signature, and operational name, parameter list, such and such. An operation signature is a combination of its name along with its parameters. In SBC process algebra, there are two kinds of interaction. Type 1 interaction it describes the interaction between an outside actor and the component. Type 2 interaction describes the interaction between a caller component and a COE component. Syntax of SBC process algebra. SBC process algebra uses 3 Backus-Naur form rules to describe the syntax. In SBC process algebra, a process is modeled as 1 to n IFD. Each IFD looks like G11 prefix A12 prefix A13, then stop. In SBC process algebra, we use transitional rule to describe the semantics of SBC process algebra. There are 2 transition rules. The first one is the prefix transition rule. The second one is the summation transition rules. Using the transition rule, the whole semantics of SBC process algebra can be described by a transition graph. A transition graph can be described by the transition relation T with 3 attributes. And we further extend this T relation from 3 attributes to 6 attributes. We summarize the description of SBC process algebra. The transition graph actually is a single diagram that SBC process algebra used to describe the whole semantics of a system. Now, let's go to the final chapter, chapter 3, projecting a system's activity diagram from SBC process algebra. We mentioned that a system's transition graph is described by the transition relation T with 6 attributes. A system's activity diagram in SysML is represented as a figure shown here. A system's activity diagram actually can be described by a transition relation with 4 attributes. The first and the fourth attribute are states. The second attribute is the operational call or return signature. The third attribute is a COI block. Therefore, the projecting algorithm from SBC process algebra to activity diagram actually is a statement of selection. Select 4 attributes from the T relation, and the T relation is a relation of 6 attributes. Thank you for all your careful listening. Bye-bye.